Hello everybody, this is the video clip number 11 of our chapter 3. In this video clip, we still consider the vector function RT, and as we have your vector function RT, we can introduce another vectors involving this vector function. Okay, the first one is a unit tangent vector. Okay, by tangent vector, it means that you need to find a derivative of your r, which is r prime t. But as you need it to be a unit, then a capital T, okay, it is a 1 over the length of your r prime multiplied by your r prime itself. Okay, so this one is a unit tangent vector. Of course, the length of the unit tangent vector must be 1, or you can say that this one is a t dot t raised to the power 1/2 equals to 1, right? So you just square it, so you have this. Then you can find a derivative both sides. Okay, as you find a derivative both sides, you do a d by dt. Okay, so you are going to have the product rule. So it's the first derivative of the second plus the second derivative of the first, which happen to be the same thing, but the derivative of the constant on the right becomes 0. So it means that the twice of your t dot t prime, it is 0. So you divide the whole thing by 2, you got t dot t prime equals to 0. So what does this mean? It means that your t prime is actually perpendicular to t. Okay, and sometimes if you talk about one vector perpendicular to another, we say that this vector is normal to the capital T. Okay, so that's why we introduce the so-called principal unit normal vector, which is usually we are going to call just unit normal vector n, to be a unit vector of t prime. So in order to be a unit vector of t prime, you just divide the t prime by the length of itself like this. So this is a unit normal vector. So it means that right now it looks like you got your RT as a curve in a three-dimensional space, and then you have your tangent vector as a unit tangent vector t, and then you got your normal vector, a unit normal vector, which is the one that perpendicular or orthogonal to the vector, the unit tangent vector t. So what else that we can introduce as you got two vectors from the curve? Actually, you can introduce another one, which is the vector that is perpendicular to both t and n. Okay, and because this vector perpendicular to both t and n, then we call it a binormal. Okay, so this was called a b, which is a binormal vector. So a binormal vector, it is defined by the first one t and then the second one n, because as you introduce, you need to find the capital T first and then the n followed by the t, right? So you start from t cross n. You cannot switch the order, okay, because the cross product is sensitive with the order. All right, so it is the t first cross the n. That will be the binormal vector. Okay, so let's look at the first example. You need to find a unit normal and the binormal vectors of the circular helix. Okay, so of course the one that you need to find first is capital T in order to find the capital N, right? So to find the capital T, you need to find your r prime, and your r prime will be negative sine and then cosine and then 0. So it means that your capital T, it is simply 1 over the length of your r prime and then the r itself. Okay, sorry, the r prime itself. So it is a 1 over a square root of sine square t and cosine square t and the 0, right? And the negative sine, cosine, and 0. Okay, so this is a simple problem. Okay, don't expect that the rest of the problem will be simple like this, because this one, the square root become 1. So this whole thing can be your capital T, right, at once. So now to find your normal. Okay, again, don't think that the rest of the problem will be easy like this. A normal, it is actually your 1 over t prime and then t prime, capital. So to find your capital T prime, it is a negative cosine, negative sine, and 0. Now the normal, it is 1 over a square root of cosine square again, sine square again, taking a square root and then multiply by negative cosine and negative sine and 0. So again, this one becomes 1. So here the rest will be your capital N, a normal unit normal vector of this curve. So now you got a unit normal vector already. So to find a binormal, which one occur first, a capital T and then followed by a capital N? So we got I, J, K, of course, but let me just write down the first term first. And the J, you have cosine, and the K you got 0. This one you got the negative cosine, negative sine, and 0. So you do the diagonal multiply. The first one 0, the second one is 0, but the last one you got the what? You got a sine square k, and then to do the upward diagonal, you got a negative cosine square k, but because it is upward, so you have a positive, and the rest again, it is all 0. So this means that what you have left, it is 0, 0, and sine square, cosine square, which is 1. This will be your binormal vector, okay, of this helix. Okay, again, this one is a simple problem. Okay, don't expect to have this kind of simple thing. All right, so let us continue. You need to find the capital T, capital N, and the capital B of this vector function R at a particular point. Okay, so this is very important. If you need to find something at a particular point, then you are going to do it at the point T under consideration. So for example, as you take a look, you should be able to see that your last component determine your T. So actually your T is simply 1, and you check again, you got the second term, second component as 2/3, and your first component as 1 again. So your T is really 1. So first you need to find the R prime. So let me do it here. So your R prime, it is 2t and 2t square and 1, right? Because this one, the 3 and the 3 will cancel, okay? And you still have that 2 left, okay? So your capital T, it is the one that you really need to find at the general point T first, okay? Okay, this is the only one that you need to do it at the general point T first. So just write down a formula again. It is a 1 over R prime and then R prime, okay? So here is a square root of 4t square, 4t fourth, and then 1. here you really need to write down. And then you got 2t, 2t squared, and 1 as your capital T. And then you are going to find a capital T at a particular point 1. Okay, so you have a square root of 4 for 1 and 2 to 1, which is 1 over 3, 2 to 1. Okay, and you don't really need to, you know, distribute the 1/3 to the rest of your vector. Okay, just keep it like that. All right, how about your n? Your n, you need to find 1 over the length of capital T prime multiplied by your T prime. Okay, just be very careful that usually, because we are going to find the unit vector, so it means that the one on the top and the one on the bottom of both of them has to be the same. Okay, just make sure. So now to find your T prime, you really need to go back to this one. Okay, so that's why we really need to have a capital T, okay, at a general point small t. So to find your T prime, you look at this formula. It is a two function multiply each other. One of them is a real value function, square root, and another one of them is a vector function. Okay, so it is simply using the product rule. So it is the first, okay, derivative of the second, which is 2 for t and 0, plus the second and the derivative of the first. So let me just do it over here. The second, which is 2t, 2t squared, and 1. Derivative of the first one, can you look at it as 4t squared, 4t fourth, and 1 raised to the power 1/2. So what you end up with is negative 1/2, and then 4t squared, 4t fourth, and 1 raised to the power negative 3 over 2. And then a derivative of the inside, which is 8 and 16, 8t, 16t cubed, and 0. You see the last one, a derivative is 0. Okay, and then don't calculate, don't add them up. Okay, you're just going to leave it like this, and immediately you are going to replace your t, the small t, each and every small t, okay, by 1. After that you can add them. Okay, so let us just replace your small t by 1. Okay, so it's going to be 4 for 1, which is a 3. Okay, a square root of 9, which is 3. 2 for 0, and then actually it is a minus 1/2, right? And then this is again 4 for 1. Okay, so it is 1 over 3 raised to the power 3, right? Because you do the square root and then you do a cube. And how about this one? 8 and 16, right? So it is 24, is it? Okay, and then don't forget this vector, so you have 2 2 1. Okay, so what is your first one? So you got 2/3. This one is 12, and you have minus 2 to the 3 cube. You got 4/3 minus, oh sorry, not 3, actually you have another 20. Oh, we can we can cancel a little bit more. Okay, so this 3, okay, this is 4, is it? So what you end up with, I mean the first one is 2/3, the second one that you need to subtract, it actually 8/3 square. Okay, and then for the second component you got 4/3 and 8/3 square, and the last component you got 0 minus 4/3 square. Okay, so this one you just multiply by 3, so you have -2 over, you got -2/9, is it? This one you again multiply by 3, so you got 4/9, and then this one it has nothing to do, so you got 4/9. And it will be better if you pull out, I mean if you can have this kind of factor, then it will be better if you pull out all the factor. So you have 2/9, and then you have -1, you have 2, you have -2. You see, you pull out that thing. So you don't really need this 2/9, because what you need is a unit vector, okay, a unit vector of your t prime. So you only need the vector, and then I mean this one is the direction, right? And then you just divide by their own length. Okay, so actually to find your capital N, add 1. Okay, you see it is the n at a particular point t under consideration. It's simply 1 over the length of -1 to -2 and -1 to -2, which is 1 over a square root of 144 and -1 to -2, or it is 1/3 -1 to -2. So this is our n. Okay, this is our n. So now you got your capital T at that particular point 1, you got capital N at that particular point 1. What else that we need? The capital B. Okay, the capital B. So actually the B came from the T cross the N. Okay, so the T, I'm sorry, let us emphasize that we are going to find at a particular point t equals to 1. Okay, so your B at 1, the binomial, your T, it is 1/3 2 to 1, cross your N, it is 1/3 -1 to -2. Okay, so actually the 1/3 and the 1/3 can be can be multiplied first to be a 1/9, and then the I, the J, and the K of 2 to 1, -1 to -2, and you do the diagonal multiply. So the first one you got -4i, and then the second downward you got positive 2j, right? And then the last one is a 4k. To do the upward diagonal multiply, so you have -2k, but it is the upward, so you have a 2k, and then you got a 2i, but it is upward, so you have -2i, and this one you got a -4j, but it is upward, so you have a 4j. Okay, so actually what you have calculate, it is negative 6 6 I'm sorry, you still have a 1 over 9, negative 6 6 6. Okay, or it is 2/3 negative 1 1 1, so you pull out the 6. Okay, so that will be your capital B at this particular point. Okay, so let me just emphasize what we have did. Okay, what we have done. So we need to find the capital T, capital N, capital B of this vector function at a particular point. This particular point corresponds to the T equals to 1. So what you have to do, this is the one that you have to, okay, you have to find the capital T at a general point T. Okay, because this one you need to use it to calculate further. So this is your capital T, just like this, and then immediately you find your capital T at a particular point 1, and then you just keep in mind to find your N, you need to go back to your capital T at a general point T first, because you need to calculate your capital T prime. And to calculate the capital T prime, please use a product rule. So this is the first derivative of the second, and then the second derivative of the first, and then don't combine as a general T. You immediately replace your small t by the one that you really need to calculate. So for example, this one, your small t is 1. So you just plug in as numbers. Okay, so everything will be just numbers, and then it will be easier, a lot easier for you to calculate. So after you got your capital T prime, then you try to pull out the factor if you can. If you cannot, you just leave it like that. Okay, and then after you got this factor, you can just ignore the factor and then look at this vector, because this vector is the direction, and all what you need is the direction over the same length. So you just have this direction over its own length, so you got this one as your N. So after you got your capital T as a, represented in terms of number at this particular point, and your capital N at this particular point, you are going to find your B also at that particular point. Okay, don't just do it as a general T. Okay, so you just use all these numbers, okay, to calculate your capital B. After you have done, that will be your capital B. But don't forget, okay, you still need this factor, the 2/3 of negative 1 1 1. That will be the whole thing will be your capital B. Okay, now look at the next example. Okay, this one you just want to find a unit tangent vector and a unit normal vector of this vector function RT. Okay, so this one go back to something that is a bit difficult again, because you're not going to find it at a particular point T. Okay, so here to find a unit tangent vector capital T, you need to find your R prime and your length of R prime. Okay, so that you can find a unit tangent. So R prime, it is simply 2 cosine t 5 and a negative 2 sine t. Okay, so the length of R prime, it is a square root of 4 cosine square 25, okay, and 4 sine square. So the sine and cosine square become 1, so it is 4 and 25, so you got square root of 29. So it means that your capital T is simply 1 over square root of 29 and 2 cosine 5 negative 2 sine. Okay. If you want to find a capital N, it is simply 1 over capital T prime and your T prime. So it means that the first thing that you need to find is your T prime, which is 1 over square root 29, has nothing to do with the T. So you got negative 2 sine 0 and negative 2 cosine. So to find the length of your T prime, so your 1 over square root 29 has nothing to do, and the length is a square root of 4 sine square and 4 cosine square. So now you got a 4 under the square root, so you have a 2. So it means that your N, it just simply 1 over square root 29. I'm sorry, let me just do the length first. So the length is a 2 over a square root 29, and then 1 over square root 29 of the vector 2 sine t, negative 2 sine t 0 negative 2 cosine t. So the 1 over will be cancelled, right? And then you got 1 over 2, 1/2 negative 2 sine t 0 and negative 2 cosine t out of it. So this is your nt. Okay. So even though your R contain the trigonometric function, however, to find your capital T and capital N seems to be easier, you see, than like what we did before without the trigonometric function. Okay. Now let us just get a spare problem. This one is look like something that you just wrap up what you have done before. For example, if you need to find the length of this curve from 0 to 1, don't forget that the length, okay, so you go back to the formula to the length of the curve. It is a integration from 0 to 1 of the small tangent line, okay, small pieces of the tangent line. So what you need to find is your R prime, which is 0 to t negative 3t squared, right? So this one, it is the integration from 0 to 1, and the length will be the first one is 0, right? So you got 4t squared and 9t fourth. Okay. The reason that we would like to let you guys look at this problem is that to remind you how to find the integration of this kind of function. So this one, actually you got a t squared and a 4 plus 9t squared taking a square root, right? Taking a square root. So a square root of t squared is actually the absolute value of t. However, under consideration, we use the positive t. So it means that actually what we can pull out is simply the t itself and 4 plus 9t squared dt. So right now you can let the function inside the square root to be your u, and then your du will be 18t dt, which is waiting for you here. So you got the 0 to 1 and then square root of u du over 18. Okay, and if you really want to, you know, make it right, then this is not really a 0 to 1, because as your t is 0, you got your u to be 4, so this is u equal. As your t is 1, you got your u to be 13. Okay, so this one, your 1 over 18 is left out, and then here is u to the 2 over 3, I mean 3 over 2 over 3 over 2, and your u evaluate from 4 to 13. Okay, so now you are going to have the 2 cancel with the 18, so you have 1 over 27. Let me write down here. So you got 1 over 27, and then 13 raised to the power 3 over 2 minus 8. Okay, because 4 raised to the power 3 over 2 becomes 8. Okay, so this is the length of this curve from 0 to 1. Okay, so again, you may need to go back and recap your knowledge about how to find the integration of this kind of term. Okay, so let's take a look at another example, just to remind you on finding a curvature of this vector function. So the curvature, it is your r prime cross your r double prime. Find the length, and then the length of r prime raised to the power 3. So all what you need to find is your r prime, which is a product rule. So it is the first derivative of the second plus the second derivative of the first. Okay, and then here the first derivative of the second, which is cosine, and then the second derivative of the first, you still has a e, and then this is 1. So now, I mean, you just combine, so you have e to the t cosine minus sine. You got e to the t cosine plus a sine. So it means that your r double prime, you are going to have the first derivative of the second plus the second cosine minus sine derivative of the first, which is e, so it's e itself. The second term, the first derivative of the second, so minus sine, and then a cosine plus the second derivative of the first, which is e again, and then the last component, you got 0. However, don't work with all these, I mean, variable t, because you look at the curvature at this particular point, and this particular point, it is when your t is 0, you see. So as your t is 0, this is 1, the first component. As your t is 0, this one is 0, the second component. So actually this one is at this particular point. So let us just replace your r prime by, I mean, at the 0. So the first one, you got 1, you got 1, you got 0. The second one, you got 1 again, and the last one, you have 1, of course. your r double prime at 0. So here your first one, you got 1, 0, and then a negative 1 here, and then you got another plus 1. The second one you got a plus 1 and a plus 1, and then the last one you got 0. So this means that the one that you really need to find is your r prime and r double prime at 0 crossing each other. So you got ijk 1 1 1 0 1 0. So it is pretty simple. Okay, you see this diagonal multiply, the first one is 0, the second one is also 0, so the one that is left over is the k. So you got a k, and then this upward, your k is gone, your I survive, so you got negative I, and then your j is gone. So actually this one is negative 1 0 1. Okay, so the curvature is simply your r prime 0 cross your r double prime 0, taking the length, and r prime 0 raised to the power 3. Okay, it's cube. So here you got a square root of 1 and 1 from here, and then your r prime at 0, you have a 1 1 1, and the cube, don't forget. Okay, don't forget this cube. So you have a square root of 2 over 3 raised to the power 3 over 2. That will be your curvature of this vector function, okay, or of this curve at the point 1 0 0, or when your t is 0. Okay, the good news is that actually we have a section 3.9. you see 3.9. However, the 3.9 you are going to study by yourself. Okay, so it's not going to be included in your test or anything. All right, so you can just read it by yourself, because it more like physics that you have learned from your physics subject. Okay, so we are going to stop our chapter 3 right here. Okay, you may need to study over and over again, and also do a lot of homework and exercise, okay, so that we can survive our, I think this one is a second test, okay, the test number 2. So we see you then on the next chapter. Bye bye.